So this is exactly what you're not going to do. You are going to study for this exam and ace it. Don't be this person or else you will get an F. F for fail. One of the most important probability distributions in stats is the normal curve. Normal curve is a theoretical probability distribution, so it's not based on empirical data. It has a symmetrical bell shape, and it's there to predict what may occur in a population. Just like probability, it's based on the idea that an infinite number of random samples have been drawn from a population, and the distribution of those scores comprise the normal curve. So the definitions I have above, those are just review from our last chapter that we learned. You're going to have to memorize all these symbols here, because you will get an exam with all of them, and formulas where you're going to have to know what each one represents. So do pause the screen and have these memorized. It's going to be useful for you to familiarize yourself with the chart I have here, because you're going to see the standard deviations with those percentages of the area of the normal curve. So just pause the screen and have a look at that. The area under a normal curve represents 100% of the cases or possible outcomes. So let's get back to talking about this picture we have here. The left side is always negative, the right side is always positive, and it's 50-50 each side because it's going to equal to 100. Those dotted lines you see are standard deviations. We use these to determine what percentage of cases will fall above or below the mean. The highest frequency is at the mean value, so right at the center, the peak of this curve. The curve has a mean, median, and mode. Because it's a symmetrical shape, the mean, median, mode, also known as unimodal, are all equal and represent a single maximum point of the curve. Those dotted lines you see are standard deviations. We use these to determine what percentage of cases will fall above or below the mean. I'm glad you guys are getting excited learning this stuff. Come on, it's getting interesting. So a raw score is the observed score of a variable measured by its natural unit of measurement. When we say Bob is 6 feet tall and Dot is 1.7526 meters tall, we are measuring the variable height as a raw score. So this chart provides you a form of proportions underneath the curve. Like say you've got the z-value of 1.44, the very first one. The proportion would be 0.42 underneath. So pretty much anything you see in the above picture, the shaded area, that is what you're finding in the proportion. So when you multiply by 100, you're going to get the percentage of the shaded region.
As you practice using this chart,
you will get more familiar with it and it will look less like alien hieroglyphics. So I just want you to pause the screen and read it and plug those numbers in. So 90 subtracted by the mean, which is 100, divided by the standard deviation of 15. And then you repeat that with 105. Then you look up the z-values in Appendix A. When I was looking for the z-score for 90, I got minus 0.67, and then I was looking for it in the Appendix A, and I saw in column 2 that the area between mean and z equals 0.2486. Same thing for the other one, where I computed 0.33 for z-score, and I was looking for it in the second column, and what I found was 0.1293. And what you do after that is you add those together, add those two values together. And what you get is 0.3779. So for the sake of keeping this video short, I have all the steps on there. I'm going to need you to pause the screen and read through it. You're going to need your z-chart again. And remember, everything I'm explaining is theory, just so you understand the main concept behind it. But it's vital for you guys to practice these formulas. Use these formulas, and that's the only way you're going to ace the exam. So practice, practice, practice.